Okay, so let's look at solving trigonometric equations with closed domains or limited domains. It's exactly the same as before, but instead of having an infinite number of answers, you're going to have just a few. Steps are the same. You're going to want to start out and isolate your trig function. So in this case, we want to isolate sine of theta. So we're going to end up getting that the sine of theta is negative 1/2. So it's always best to think about it generally first. So that would be like if we were to answer for all real numbers. So for this one, you would have theta is going to be either 7 pi over 6 plus 2 pi k, or 11 pi over 6 plus 2 pi k. And this is where k is some integer. So basically these are our two answers on the unit circle, and these, the plus 2 pi k's, represent all the coterminal angles that are possible. So that's how you would answer generally. Now, if you were to, let's say, see from 0 to 2 pi, like this is just answers on the unit circle. So we don't need all the coterminal angles, we just need the angles that we know in the unit circle. This is the most common interval that you're going to see. So knowing the unit circle is important, but sometimes you're going to have, domains that are not normal. So this one is negative pi to pi. So we are now going this way. So negative pi all the way to 0, and then all the way back to pi. So counting in it, we're still counting about the same distance, the same number of angles, just in a different order. So we've got to figure out how to make this answer work for us. Well, that's where our k comes into play. So we go up and we look at these k's. Well, if we plug numbers in for them, then we can find what we need to know. So if we have, just on the unit circle, these angles here, so the unit circle, that's a k value of 0. Any other k value, so like k of negative 1 is, like 1 back, or 1 rotation back. And k equals 1 is 1 forward. And so this way we can use these values of k's to find the numbers that we need. So in this case, these angles, the ones that are on the unit circle, do not fit in here because both of them are over pi. So what we have to do is think of a value of k below 0, or 1 being negative 1. So we're going to get theta to be 7 pi over 6 minus 2 pi, because again, k is going to be negative 1, or 11 pi over 6 minus 2 pi. And these answers, if we were to look at the fractions and add and subtract, we would get here. This would be negative 5 pi over 6, and this is going to be negative pi over 6. So you can see how these answers change very much so depending on which interval we're talking about. If we're talking about just a general solution where we don't have a range, or we don't have a domain, then you have to add these possibilities from coterminal angles. If we're talking about the unit circle, then you should know these right off the top of your head. And if it's altered slightly, you just kind of have to use what you know about the general solutions and the unit circle to find your answer. So let's look at another example here. So we've got 3 cosine 3 theta equals 3. Or excuse me, 6 cosine 3 theta equals 3. So again, we want to isolate cosine. So we're going to get the cosine of 3 theta equals 1/2. And so we will get 3 theta to be two possible answers in the general sense. It'll either be pi over 6, or excuse me, pi over 3 plus 2 pi k, or it will be 5 pi over 3 plus 2 pi k. Now, we're not interested in what 3 theta is. We're interested in what theta is. So when we divide by 3, our new answers are going to look something like this. we're going to end up with pi plus 6 pi k all over 9. And we're going to end up with 5 pi plus 6 pi k over 9. Now, these answers, I've shown how to find these in previous classes. Basically, when you divide by 3, you end up multiplying actually each term by 3 to kind of free up these fractions, and that's why you end up with answers that look like this. This is a good way to think about it because now I can adjust these very easily for these different forms. Now, because I have this 3 theta here, that means that I'm going to have 3 times as many solutions in a normal range that I would. So for here, because of this 3, I'm going to have k is going to be 0, 1, and 2. So 3 options here are going to be made, and that is going to help me find all my answers pretty quick. So for my k being 0, I've got 2 options. So I'm going to have pi over 9 and 5 pi over 9. So pi over 9 and 5 pi over 9. For k equals 1, I'm going to have 7 pi over 9 and 11 pi over 9. And for k equals 2, I'm going to have 13 pi over 9 and 17 pi over 9. So these answers are all within this range, as you can see. 17 over 9 is still less than 2. So because I have this 3 theta, that's going to give me 3 times as many solutions as normal. So I have to consider 3 rotations of the circle. So the unit circle, the next one, and then the next one, in order to make sure I'm packing all my answers. And the next solution is going to be pretty similar, except I've got to make sure that I'm going not only forward a little, but backwards. So I've got to include what values that I know. Now, the tricky thing is that I'm not necessarily sure that any of these will work because I'm going up to 1. So I just need to make sure that I'm including all the angles that work from 0 to pi, and then going backwards from that. So you just want to make sure that you're taking your time. So if I go up to this list here, I know that pi over 9 will work. I know that 5 pi over 9 will work. And I know that 7 pi over 9 will work. But you can see 11 pi over 9, 13 pi over 9, and 70 pi over 9, they're too big. They're too big for this because they're greater than pi, so I've got to go backwards. Now, if I go backwards, I need to look and so, like, what if k were to be negative 1? So if it were negative 1, I would get negative 5 pi over 9. Okay, so I've got negative 5 pi over 9. That works. If it's negative 1 here, this is negative pi over 9. Now, if I were to keep going, so if I went 6 more down from that, so if I turned k into negative 2, so if k into negative 2 is going to give me so this would be negative 11 pi over 9. That's not going to work. For this one, I could do k to be negative 2, and that would give me negative 7 pi over 9. And these are all my possible answers for this part. So this one is a little bit trickier because it's not very standard. I've got to kind of mix up all these different options and just make sure that they fit there. For our last example, we got an equation sine squared of 4 theta minus 1 equals 0. And we're only looking at the options on the unit circle. So again, we've got to isolate sine first. So we're going to get sine squared of 4 theta equals 1. If we take the square root of both sides, we'll have sine of 4 theta equals positive or negative 1. So we've got lots of options here. So we're going to have 4 theta, 4 theta is going to equal, so the sine is going to be positive 1 at pi over 2 plus 2 pi k. and it's going to be negative 1 at 3 pi over 2 plus 2 pi k. Well, like before, I've got to divide everything by 4. And when I do this, I'm going to get theta to be, it's going to be pi plus 4 pi k over 8. And I'm also going to get 3 pi plus 4 pi k over 8. So this I now have to adjust because I'm looking at a limited domain here from 0 to 2 pi. So these are the answers on the unit circle, ones that could appear there somewhere. If I look up at the top, I've got 4 theta. So that means there is actually 4 times as much going on in this sine function than there would normally be. So I've got to include that k could be 0, 1, 2, or 3. Right, so these are 4 full rotations. So 0 is the unit circle, then 1 beyond that, then 1 beyond that, then 1 beyond that. So this is going to include 4 things. So k can be all of these values, and I've got to list them for each of these. So I'm going to end up with 8 total answers. And you need to make sure you write out all 8 answers because they all would create a solution for this. So if I go down the list, if k is 0, I'm going to get pi over 8 and 3 pi over 8. I then do k as 1, so I'm going to get 5 pi over 8 and 7 pi over 8. I'm then going to have, so k can be 2, so I'm going to have 9 pi over 8 and 11 pi over 8. And then for k to be 3, it would be 13 pi over 8. And lastly, 15 pi over 8. So these are all of my answers. Now, normally you get 2 answers per unit circle, but because I had 4 thetas, I'm going to have 4 times as many. So that's where you end up with the 8 answers. So listing it like this right off the bat really helps you kind of track your answers down, especially when you have these multiple angles. So it's a good habit to keep.